Dr. Entrance and Beyond, and welcome to my DSA series. So, today I will be discussing the question 136, that is single numbers. So, let's dive right in. So, the question says given a non empty array of integers nums, every element appears twice except for one, find that single one. You must implement a solution with a linear runtime complexity and use only constant extra space. So, let's look at the test cases. So, example 1 int nums is equal to 2, 2, 1. So, as you can see, the element 2 appears twice, so its frequency is 2, and the element 1 appears once, and that is the element we have to return, so the output is 1. Let's look at another test case. So nums is equal to 4, 1, 2, 1, 2. What we can see is frequency of 4 is 1, frequency of 1 is 2, and frequency of 2 is 2. So we're going to return the element whose frequency is 1, so that would yield us 4, and then there's another similar test case. So the most intuitive solution to this question would be, let's just sort nums and compare adjacent elements. If the adjacent elements are not the same, that means we have arrived to an answer, because all the elements except one appear twice. So adjacent elements must be the same for all the numbers, just except for one number, the number which we are supposed to return. So I won't be writing the code for that. You can try that out yourself. And if you face any problems, we'll be mentioning the code in the comment section if that is the case. I'm going to explain two other approaches to solve this question. So the first one is using an unordered map, or something known as a hash map. So if you don't have an idea about a hash map is basically a data structure that stores key value pairs. So it's similar to a dictionary if some of you are familiar with Python. So it's similar to that. So that is pretty much what a hash map is. And there are two types of hash maps. So unordered map and ordered map in C++. The only underlying difference between both of these is that in an unordered hash map, the keys aren't ordered, or they're not in some particular ordering. And if we have an ordered hash map, the keys get ordered, and that would take more time because, again, you'd have to sort the keys when you're adding new elements. So we're going to use unordered map in this case because we don't really care about the ordering of elements. So let's discuss that approach. So suppose we have the array 2, 2, 1, 2, 2, 1. So in this question, we clearly know we have to store the frequency of each of the elements, or frequency basically means the number of times the given element appears in our array. So if the frequency of an element is 2, we don't care. If the frequency of a given element is 1, we're going to return that. So in this case, we're going to basically iterate through our nums array. So 2, so 2's frequency initially is 0, so now it becomes 1. We encounter another 2, so this becomes 2, and then we encounter a 1, so the frequency of 1 is set to 1, and now we're going to traverse through this. So we look at 2, frequency is 2, that's not our answer. 1, frequency is 1, so that is our answer. That is basically the unordered map approach. It's going to take big O of n time, both space-wise and time-wise, because in a hash map we're literally storing all the unique elements. So we can say big O of m instead of n, where m stands for unique elements. So this was our first approach. And the other approach involves using something known as XOR. So if you're not familiar with XOR, XOR is basically a bitwise operator, and this is its truth table. So 0 XOR 0 basically gives us 0, and 1 XOR 1 also gives us 0. 1 XOR 0 or 0 XOR 1, they basically give us 1, and this is 0. So XOR is simple. So if both the elements are the same, we get 0. If both the elements are different, we get 1. And since we are talking at the bit level, we only consider 1 and 0. So an interesting property about XOR is if we do X XOR X, what would it be? So X XOR X would always give us 0. Now you might be wondering, why is that the case? Because when we compare X and X, the corresponding elements at a given bit would always be the same. And we basically know that if we XOR two things that are the same, so if we do 0 XOR 0 or 1 XOR 0, we're going to end up getting 0. So for example, if we do 2 XOR 2, that would basically be converted into 1 0 XOR 1 0. So 0 0 0 1 0 0. So that's the simple property that we get. So if we XOR X with itself, we get 0. So this is the first property that holds true. And another property is if we do 0 and XOR that with some value y, suppose, it's always going to give y. And why is that the case? It's quite simple. As you can see, when the numbers were distinct, or when the number was XORed with 0, we got that same number. So 1 XOR 0 is 1, and 0 XOR 0 is 0. So this is what we are going to use to solve this question. So suppose we have an array that is something like this. So we have 4, 1, 1, 4, 2. So if you think about performing XOR, it won't directly make sense, but we can think about it like this. So it doesn't matter though. It like addition, we could XOR any two elements together, correct? So if we have something like 1 plus 2 plus 1, the order doesn't really matter. So that's the same thing or same case with XOR. So what you can notice is that if we XOR 4 and 4, so that is X XOR X, we always get 0. And if we do 1 XOR 1, that would always yield 0. 0 XOR 0 is always going to be 0. And then 0 XOR 2 would be 2. So if we basically perform an XOR throughout, or if we basically take XOR as 0, and then we perform an XOR with all the elements present in this given array nums, the output would be the element that appears once, because all the other elements appear twice, so their XOR would yield 0. 0 XOR any number of zeros would be 0, and then 0 XOR the remaining number would give us that remaining number. So that is the required output. So now let's code this up. So we're going to take something like this, int answer. Int answer, set it up as 0. Then we're going to do for int I is equal to 0. I is less than nums dot size. We're going to do I plus plus. We're going to then do answer XOR equal to nums of I. And we're just going to return answer, and that would be the correct output. So this should run perfectly fine. As you can see, it runs perfectly fine. It also shares the unordered map approach. So this is how you declare an unordered map. So unordered map, then you have this less than sign, and then you have the mapping. So the key would basically be an int, and the value would also be an int in this case. And we're going to call that frequency. Now we're going to traverse through nums. So int I is equal to 0. For the time being, let's again use a variable to store our final answer. Int answer I is equal to 0. I is less than nums dot size. We're going to do I plus plus. Then we are going to do frequency of nums of I plus plus, because that's the element whose frequency increases. We can now traverse through the element again. So it's simple. For auto x in frequency, we're going to do if x dot second, so that is the corresponding value for a given key. X dot second, if that is equal to 1, we are going to store that in answer. The answer is equal to x dot first. That tells us the element that would be our answer. Then we're going to break, and in the end we can simply return answer. And let's try to run it and see if we get the correct answer in this case. So it's running, yeah, we get the correct answer. The only problem is we're taking a bit more time. So thank you so much for tuning in. Hopefully you understood the question. If you didn't understand the question, you can mention that in the comment box. And if you did understand the question, you can also mention some other questions that you want to be discussed in future videos. So thank you so much for tuning in.